In order to determine the oxidation state of our atoms of interest, we must follow the rules of the flowchart. And if you're unsure exactly what an oxidation state is, then I recommend that you check out the video in the description. This chart is a top-down model, meaning that the higher up in the chart the rule is, i.e. the lower the number, the more important it is. Our most important rule, Rule 1, states that if our molecule contains only one type of atom, the element has a zero oxidation state. For example, this is just simply carbon, so it's got a zero oxidation state. Yes, there are two CLs, but because it's just Cl, it's going to be zero oxidation state. You may have noticed that Rule 2 and 3 are of equal importance. How does that work, and wouldn't that complicate things? Well, the good news is that they're categorically different with the substances that we deal with, as we'll never have to put them up against each other. Rule 2 deals with molecules, which have a zero charge overall, and Rule 3 deals with ions, which don't have a zero charge. They have a positive or negative charge. Rule 2 states that the sum of the oxidation states of the individual atoms which make up the molecule have to add up to zero. For example, the overall charge of the molecule is zero, so it checks out that 0 plus 1 minus 1 equals 0. Rule 3, on the other hand, is the exact same thing, only we're dealing with ions. Single ions, polyatomic ions, where the sum of the individual atoms' oxidation states has to add up to the overall charge of the ion. Altogether, Rule 1 deals with things that just have one type of element. Rule 2 deals with molecules, which have a zero charge, and Rule 3 deals with ions, which do have a charge. In that sense, Rules 1 through 3 are of equal importance, and the first thing that you have to do to determine the oxidation state is just to figure out what type of substance it belongs to. Here's another way of visualizing that. Once we figure out what type of substance our element of interest belongs to, we'll be able to figure out the oxidation state very clearly. If it belongs to a pure substance, the oxidation state of our element is going to be zero. If not, we're going to follow through the rest of the chart. As an example, let's determine the oxidation state of sodium within NaCl, salt. We know that it's a molecule because it's a compound. It has more than one type of element, so it's not a pure substance, and it's got a zero charge. Likewise, the sum of the oxidation states of the individual atoms which compose the molecule have to add up to zero. As we go through with the remaining rules, this looks a little bit daunting, but it turns out that with NaCl, only Rule 5 and Rule 8 are relevant. Rule 5 tells us that Na is going to be +1 oxidation state, whereas Rule 8 says that chlorine is going to be -1 because it's a halogen. And that checks out, so +1 is going to be our answer.